So in this video we're going to look at how we change the subject of a formula. Sometimes this can also be described as rearranging a formula. And the first thing we're going to look at is how we identify within a formula or equation what the subject is at present. So basically when one of the terms is the subject of the formula, this is the term that is on its own. So this is the term that is in, it is equal to everything else. So if we look at this one, I took some formulas that we should be familiar with from other topics. Y equals mx plus c, that being the formula of a straight line. Y is the subject in this formula because it is a term that is on its own. The next one, s equals d over t, speed equals distance over time, again another one we should be familiar with. S is what is currently the subject in this formula. And again, I've just taken this last one, pi r squared is equal to a, and I've just rewritten it in a slightly different format. It doesn't matter if the term that's on its own is on the left or the right hand side. In this case, a is the subject, a is the term that's on its own, it's a can equals pi r squared is what it can preferably be written as. It's not necessary, but it is best practice to leave the subject on the left hand side of the equals. So we're going to do that for any of the formulas that we're going to rearrange today. Okay, so again, doesn't matter if we write this like this or swap the left and the right hand side of the formula around. Essentially they're both the same things because an equals means the same as. Okay, so that's what the subject of a formula is, the term that is on its own. So in each of these examples today we're going to make x the subject. Now it might necessarily be x, it might be a different term within the formula that you're asked to make the subject, but the method is exactly the same. If I want to make x the subject of this, okay, so y equals x plus 2, that means I need to get x on its own. So it's a good idea that if you haven't already to watch the previous video on solving equations, solving two-step equations and the likes of that, because again the method of what we're doing in that video is pretty much the same as what we're doing here. If I want to get x on its own, I need to get rid of this 2 on the right hand side, and what you're doing is you do the opposite of whatever that term is doing. So to get rid of a plus 2, the opposite of plus 2 is minus 2. But again, just like in terms of solving an equation, what I do to the right hand side of an equals I also have to do to the left hand side. So what happens on the left hand side is this becomes y take away 2. So y minus 2 is equal to x plus 2 minus 2 is 0, so it is gone, and that's why we do that. So y minus 2 equals x. And again, as I pointed out earlier, it's better just to swap the left and the right hand side around to write it like that. So x equals y minus 2. X is now the subject of the formula. Okay. The next example, so quite similar to the one above, we're going to make x the subject again. So w equals x take away 4. We need to get rid of this minus 4. To get rid of minus 4, I simply plus 4, but remember what I do to one side I have to do to the other. So what I'm left with on the left hand side is w plus 4 is equal to x minus 4 plus 4 is 0, so it is gone. And again, what we're going to do is we're just going to swap the left hand side around with the right hand side to make the term that is now the subject on the left. Okay, x equals w plus 4. Moving on. So again, this time we have t equals 3x. I want to get x on its own, so I need to get rid of that 3. So again, just keeping in mind, and just like solving an equation, I want to get rid of that 3. That 3 is multiplying with the x, so the opposite of multiplying is dividing. Just keep in mind what I do on the right hand side, I have to do on the left hand side. So I have to divide by 3 over here as well. So I can write that as t divided by 3, or again, as pointed out in previous videos, I prefer to write it as t over 3 like that, because remember the line within a fraction is known as the dividing line, is equal to, sorry, that 3 is now gone, is equal to x. Alright, we're going to swap the left and the right around, so what I'm left with is x is equal to t over 3. So dividing by 3 gets rid of multiplying by 3, it cancels it out. Okay, so that's what we're doing. Whatever the term that we're trying to get rid of is doing, whether it's adding, subtracting, multiplying or dividing, we are doing the opposite of that. Sticking with that, if I look at this fourth example, u is equal to x over 4. X over 4, just like I pointed out above here, this line means divide in a fraction, so to get rid of divide by 4, I multiply by 4. But again, if I do that to the right hand side, I have to do it also to the left hand side. So 4 times u is just written as 4u is equal to x divided by 4 multiplied by 4, cancels out, so I'm just left with x on the right hand side. And again, we're going to swap it around, so we put the term x that is now the subject on the left hand side. Okay, moving on, I have y equals x squared. So the opposite of squaring something is square rooting. Okay, but if I square root the right hand side, I also have to square root the left hand side. So the square root of y is simply written as root y. The square root of a squared term just brings it back to its original format. So if you square root x squared, you're just left with x, because again, kind of like above, the multiplying and the dividing, the squared term and the root cancel each other out. So I'm left with root y equals x. And again, I'm going to put the x first by swapping the left and the right hand side around. So x equals root y. Okay. Last example we're going to look at today, okay, is, and this is where we're going to pick up with the next video, because I'll do a series of videos on this as they get progressively more difficult and there's more involved in them, is where we have 2 steps to getting the x on its own here. So again, this is why it is important to watch the video on solving 2-step equations, because there will be 2 steps to getting an x on its own here. I have a equals bx plus c. I need to get rid of the b and the c, and because we're working backwards, we're going to get rid of this c term first, the plus c. So to get rid of plus c, I subtract c from the right hand side, but remember, I also have to do that from the left. So a take away c, it's just written as such, is equal to b x, I haven't done anything with that b yet, plus c minus c is 0, so it is gone. And now what we have to do is we have to get rid of this b. Because this b is multiplying with the x on the right, to get rid of it, we divide by b. And we have to do the same to the left hand side as well. And this is why, a perfect example of why it's better to write it as a fraction when we're dividing, because we are dividing the whole thing by b, so we can just do it like that. Otherwise, we would have to put brackets around and then the a and the c and write divide by b. So it is better to write it like a fraction. Like that. B divided by b is 1, so it's 1x, which is just x. Alright, and just like the previous examples, we're going to put the x first, so we're going to swap the left and the right hand side around, and we get x is equal to a minus c all over b. Okay, so I'll put a couple of questions here to try, and anything you're unsure about, just ask.